Alright, so in this video we are going to talk about negative and zero exponents. So negative exponents, we have already seen anything raised to the zero power is 1, but I just want to show you it in a different way now that we know the quotient property. So if I had 5 to the second over 5 to the second, well, just naturally, we know anytime we divide a number by itself, so 5 to the second and 5 to the second is the same number, we get 1. But according to our quotient property, when we divide like bases, we're also supposed to subtract their exponents. So when we do 2 minus 2, since they're the same base, we get 0. So, since 5 squared divided by 5 squared is 1, and 5 squared divided by 5 squared by our quotient rule is 5 to the 0 power, it follows naturally that 5 to the 0 and 1 are the same thing. So anything raised to the 0 power has to be 1. So just to look at a couple examples, if I have 4 times x to the 0 power versus if I have 4x to the 0 power. Only one of these is going to be equal to 1. This one is going to be the one that's equal to 1 because the whole thing has parentheses around it, and so that tells us that the whole thing is raised to the 0 power, so our final answer here needs to be 1. For the top one, only x to the 0 is equal to 1. So this term right here with the x is equal to 1, but the 4 remains. So 4 times x to the 0 is actually equal to 4. So which of the following would be equal to 0? Select all that apply. So A, the only thing raised to the 0 power in A is y. So that's going to be the only thing that's equal to 1. So A is actually equal to 5x. For B, 6 to the 0 power, anything raised to the 0 power is 1. For C, the only thing raised to the 0 power is x. So that's going to be equal to 1, but it's going to leave us with the 3 remaining. And then D, the whole thing is raised to the 0 power, so that tells me my final answer is going to be 1. So the two that were equal to 1 were B and D. Alright, so negative exponents are kind of unique. So let's look at another quotient rule. Let's say we have 5 to the second divided by 5 to the fifth. Well, according to the quotient rule, since they're like bases, we can do 2 minus 5, which is negative 3. So 5 to the second divided by 5 to the fifth is the same as 5 to the negative 3. But let's actually write this a different way. Let's write it in expanded form. So 5 to the second over 5 to the fifth is equal to 5 times 5 over 5 times 5 times 5 times 5 times 5. So as we talked about with the quotient rule, a number divided by itself is 1. So when we have 5 divided by 5, that cancels to make 1. And another 5 divided by 5 cancels to make 1. So that leaves 5 to the third in the denominator. And since nothing is left in the numerator, there's really going to be a 1 left up there, because we wouldn't put 0, because 0 would just make the whole thing cancel out. So what that tells us is if 5 to the second divided by 5 to the fifth is the same as 5 to the negative third, and that same thing, 5 to the second over 5 to the fifth, is equal to 1 over 5 to the third, then what we can conclude is that 5 to the negative third power is the same as 1 over 5 to the third power. This is called a reciprocal. You probably have seen reciprocals before, but you would have seen it in the context of taking a fraction and flipping it over. So like 2/3 and 3/2 are reciprocals. But we kind of have the same thing going on here. We have 5 to the negative 3 and 1/5 to the third. And so a negative power is its reciprocal. So let's just look at a couple examples. So if we had x to the negative third power, if we want to write that as not having a negative power, we take the reciprocal of x to the third power, which is 1/x to the third power. So x to the negative third is equivalent to 1/x to the third. If I had 2 to the negative second, sometimes people want to say that this is equal to -4, but that's not what a negative exponent means. A negative exponent means the reciprocal of 2 to the second. So the reciprocal is going to be 1/2 to the second, or 2 squared is 4, so it's actually 1/4, which makes sense because 2 to the second is 4, and so the reciprocal of 4 is 1/4. If I had 3 to the negative fourth power, again, that is not -81. A negative power does not mean make the base negative. It means take the reciprocal. So it's going to be 1/3 to the fourth. And 3 to the fourth, 3 times 3 times 3 times 3 is 81. So this is really 1/81. We're not going to do a lot with this, but if we were to ever have a negative in the denominator, the reciprocal of this basically takes it from the denominator and flips it up to the numerator. So this is actually x to the fourth power. You'll see this more in Algebra 1 next year. So please copy these definitions into your notes. A zero exponent tells us anything raised to the 0 power equals 1. So if I have a to the 0 power, that's equal to 1. Again, something you'll see in algebra is technically a cannot equal 0. So 0 to the 0 power is not equal to 1, but that's something you'll see more of next year. And then a negative exponent, we should be thinking reciprocal. So if we had a to the negative n power, we take the reciprocal of a to the n power, which is 1/a to the positive n power. So to make an exponent positive, we're essentially going to move it to the denominator. Unless it's already in the denominator, which if we had 1/a to the negative n power, we would move it to the numerator to make it positive.